All right, today I'm going to be going over a technique called completing the square, and I'm going to be doing a visual approach. It's not going to be the way that most books like to teach it, so I'm going to use a visual approach on explaining and completing a square. So if this is my square and I wanted to know the area of it, and let's say my side length is 5, that means the other side length is 5. And if I multiply those two together, what I get is 25, all right? Also known as 5 to the second power, all right? If I drew another square and it was a 3, then its area would be 3 to the second power, which gives me a 9, all right? Now, for any square, I don't care what number it is, right? For any square, if I put an x there, then basically the area is going to be x to the second power. And that'll give you the area of any square. That's why a second power is considered a square. Now, what if I extend that idea to look like this one instead? Now, instead of it saying x times x, it says x plus 3 times x plus 3. How do we find the area of that? So what I do is, basically, I'm going to break this up into 4 smaller squares, and then I'm going to write my x plus 3 like that now, all right? So if I break it up into 4 smaller squares, it allows me to do this piece by piece. X times x is x to the second power. X times 3 is 3x. And that's a positive. Then I have this 3 times that x. That's another positive 3x. And then if I do 3 times the 3, I get a positive 9. So what I did was I broke it down into smaller squares, and then I did it piece by piece. Now, what we can do is put this back together, and it starts off with x to the second power. 3x plus 3x is 6x, right? And now I got a plus 9 on the end, all right? So basically, I'm extending the idea of multiplying two quantities times itself. That's it. Just multiplying a number times itself, whether it's a regular number, whether it's a variable, or whether it's an expression as you see here. It's still x plus 3 times x plus 3. So we're extending the idea out to expressions now. So completing the square is basically taking an expression similar to this and getting rid of that number, and then us figuring out what that number needs to be for this to be a perfect square. So once again, I go right back into my visual diagram, my square. I'm going to draw a box. And so we're going to start with the easiest one first, which is x to the second power. That's real simple. X times x is what gives me that x to the second power. Now, that's a 4x. But remember, we got to figure out a way to split it so that we can get that evenly, similar to what we did here. See that? So for me to get a 4x, I really need to have a plus 2 and a plus 2 again. And you'll see why in a moment. So let's look at this real quick. What I have is x times x, which is x to the second power. I have x times a positive 2, which is a positive 2x. I have positive 2 times x, which is a positive 2x again. But then look what happens here. We start to see. Remember, we have a question mark here, and this number times that number is going to fill in that question mark, plus 4. So let's think about what's happening in the box. I have x to the second power. If I add 2x plus 2x, what I have is a 4x. And then the square was completed when I was able to fill in that missing box, which is a plus 4. So for me to complete this square, this number needs to be a plus 4. And the reason why we call it completing the square is because let's look at what the box says. I have x plus 2 times x plus 2. I have x plus 2 times itself. We've turned this expression into a perfect square. Remember, second power indicates a perfect square.